Hi, welcome to my video on how to find the inverse of a function from an equation. And to do this, I'm going to use the linear function. This is the simplest one to do. Find the inverse of a function from an equation. Steps: change the f of x to a y, or f of x could be g of x, h of x, any notation. Change x to y and y to x, that's interchange the x and y. Solve for y and change the y to f negative 1 of x, that's the inverse. Remember, the inverse of f of x is denoted by f to the negative 1 of x. Let's do the first one. Find the inverse of f of x equals 1/3 x. So f of x we change to a y, 1/3 x. Notice this is a linear which has a slope of 1/3 and a y-intercept of 0. So we change the f of x to a y, we change the y to an x, and an x to a y. We have a fraction denominator of 3, so we'll multiply both sides by 3. So we get 3x, 3 cancels, and I got a y. So that's y equals 3 to the x, and the y is f to the negative 1 of x equals 3x. Notice the slope here is 1/3. Notice the slope here is 3, because this is a multiplication, so it's a reciprocal, 3. Find the inverse of the g of x equals 4x minus 7. So the inverse is g to the negative 1 of x. So we change the g of x to a y. We change the y to an x and an x to a y. Now we have to solve for y. So I can leave the y where it is to keep it positive. So I can say x plus 7 equals 4y. Then I divide by 4. And I have 4's cancel, y equals x divided by 4 is 1/4 x. 7 divided by 4 is 7/4. So that's the same as y equals 1/4 x plus 7/4. And it's the g of x because this is g. So the g of negative x, that's its inverse, is 1/4 x plus 7/4. And find the inverse of the h of x equals negative 2/5 x plus 3. And again, the inverse is h to the negative 1 of x. Change the h of x to a y. Switch the y and the x's. So y becomes x, x becomes y. Because reasons do that because of reflection in the line y equals x. Y equals x, x equals y. And now we solve. X minus 3 equals negative 2/5 y. So we can multiply by 2 and divide by 5, or we can multiply by the reciprocal, which is negative 5/2, negative 5/2. The negative times the negative positive, so that gives us, this cancels out to be a 1, so that's a y. So we get a negative 5/2x plus 15/2. And so that's y equals negative 5/2x plus 15/2. And it's an inverse, so it's h to the negative 1 of x equals negative 5/2x plus 15/2. Notice the inverse, g of x, this is the inverse, g to the negative 1. F of x, f to the negative 1. So we know when we have f of x and f to the negative 1, we know they're the inverse of each other. If you left them in terms of y, like this, y equals 3x and y equals 1/3 x, we really don't know if they're the inverse of each other unless we do some more work. Okay, so let's continue. Number 4, find the inverse of the f of x equals 2x plus 4. And again, This is a linear, so we change the f of x to a y. We change the y to an x to a y. Solve for y, so I'll leave the y there. Now if I want, I could move the y over here and move the x. So the y goes to the left, the x goes to the right, change. Now we divide by -2. So y equals a half x minus 2. And so its inverse is f to the -1 of x is a half x minus 2. Now it says find the coordinates of the intersection of the f of x and f to the -1 of x. Notice the f of x is a line. Y equals, the slope is 2, the y-intercept is 4. Right here the slope is a half, the y-intercept is -2. So the intersection is going to be no point, or it's going to be 1 point. Two lines will intersect if they do in a point. If they don't intersect, because they're parallel to each other. So that means the f of x is equal to 2x plus 4. F to the -1 of x is a half x minus 2. So if they're the intersections when they're equal, so 2x plus 4 is equal to half x minus 2. The LCD is 2. So we'll multiply 2 by each side. So 2 times 2x is 4x. 2 times 4 is 8. 2 times a half is 1. 2 times -2 is -4. So we'll solve for x. So we move the x's to the left, numbers to the right. So 3x equals -12. Divide by 3, x equals -4. Now we want to find what the, so we also could have said y equals 2x plus 4. We could have said y equals a half x minus 2. So really, I can put in the f of x equals 2x plus 2. So I'm trying to find what the y is. So the f of -4 is 2 times -4 plus 4. -8 plus 4 is 4. So the point of intersection x is -4, y is -4. Or I could have wrote y equals 2x plus 4. The f of x, so f of x is 2x plus 4. So I can change the f of x to a y. Now I can sub in when x is -4. So it's the same as right here. It's your choice. And we get x is -4, y is -4. But this is the same because the f of -4 is the y. So x is -4. The f of -4 is the y. So the y is -4. So the inverses, both of the f of x and its inverse intersect at -4, 4. That means that a -4, 4 plugged in here will make it true, and plug it into the inverse here, it will make it true. Okay, let's continue. Now we have the final one. The f of x again is equal to x plus 3 is a linear. And so we got to find the inverse. So the f of x is a y. Change the y to an x and an x to a y. And I could, if I want, I got two choices. I can leave the y where it is and go x minus 3. So y equals x minus 3. So the f to the -1 of x is x minus 3. So f of x is x plus 3. F to the -1 of x's inverse is x minus 3. So let's solve both of these. Either this is a linear, and this is a linear. Slope here is a 1, y-intercept is 3. Slope here is 1, y-intercept is -3. So algebraically, they're either going to intersect in a point or not at all. So the f of x is x plus 3. F to the negative 1 is x minus 3. Let them equal to each other. X minus x equals negative 3 plus 3. 0 equals, oh, there's a minus 3. It just made a little error there. Bring the 3 over, make it a minus. So that's minus 6. So 0 equals negative 6. No solution is impossible. So there's no solution. There's no point of intersection. So the no point of intersection, and why? Well, geometrically, if the f of x equals x plus 3, then y equals x plus 3. The slope, we have y equals mx plus b. So the slope is 1 and the y-intercept is 3. F to the negative 1 of x equals x minus 3. And again, y equals x minus 3. So the slope is 1 and the y-intercept is negative 3. And because the slopes are equal, the slope of f of x and the slope of f to the minus 1 are equal. That means the lines are parallel to each other, hence there's no solution because the slopes are equal. Now, if I graph this line here, the y-intercept is 3, which is right here. 1, 2, 3, right here. The slope is 1 over 1. So if I rise 1, run 1, rise 1, and run 1. So this line, allow me to draw the line going through that. So there's that line. So that's the line y equals x plus 3. Now I'm going to graph this one. The slope is 1 and the y-intercept is negative 3. So the y-intercept is negative 3 right here. The slope is 1 over 1. So we rise 1, run 1, rise 1, run 1, rise 1, run 1. So I draw the line going through those points. And I have this. So this is the line y equals x minus 3. As you can see from the graph, the two lines are parallel to each other, again because they have the same slopes, different y-intercepts, so there's no solution. So that's algebraically, for this system, I got 0 equals negative 6. That's impossible, so there's no solution. They don't intersect. Geometrically, on a graph, or explaining in terms of slopes, they have parallel lines and they don't intersect, so there's no intersection. So the f of x and f to the negative 1 on this equation or this graph have no intersection because they're parallel to each other. So I just wanted to work on the linear function because it's easy to work with at the beginning. Solving, finding the f of x, f to the negative 1 of x from an equation. Again, you see the pattern I'm going to use. And again, if you like my video, click on the like button. If you're not a subscriber, you can subscribe to my channel. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.